Let's take an example. Now, let's assume that I am 30 years old currently and plan to retire at the age of 55. So 25 years from now, I plan to retire. Post-retirement, I want an amount of 25 million per annum for the next 20 years. So if I were to frame this problem, this is where I am 30. I want to retire at the age of 55, and post-retirement from 55 to 75, I want 25 million per annum. Just using hypothetical numbers, I'm sure this is far more than what anyone would need, but 25 million per annum for the next 20 years. I am willing to invest 2 million each from now till the next 15 years. So till the age of 45, I am willing to invest 2 million each. How much do I need to invest in this period between 45 and 55, assuming investment returns of 10% can be earned on this portfolio? Another assumption is that withdrawals and investments into the portfolio are happening at the end of the year. Technically, you could also take beginning of the year. It doesn't really change things dramatically. But for simplicity, to begin with, we will assume that the investments and withdrawals are happening at the end of the year. That's the problem statement we are looking at. Let's try and solve for this. So effectively, what we see is this. We have a period of investments. We have a period of investments. This is where we are standing now. We are saying from year 31 till year 45, I will invest 2 million at the end of every year. I am willing to do that. We are also saying that from the year 56 onwards till the year 75, after my retirement at 55, I want to withdraw 25 million every year. So this is what we are trying to solve for, and we have to find out this investment here. What do we really do in this period? How do we really invest, and what amount do we invest at the end of each year? Now, how do we solve it? The solution for this is that this set of cash flows first gets discounted to the point of 55 years, this point. So I find the present value of all this annuity at 55 years. I find the future value of this entire annuity at 45 years. So this is the future value of the current annuity. Let's call that FV1. Let's call that PV2. I want to then take PV to 45 years. So I find something called PV2 dash. Effectively, this is the present value of all these 25 million cash flows at the age of 55. I will discount it back to the age of 45. The difference of these two is what is supposed to be invested during these years. I can find the present value of this. The present value of this is what is the difference. Once the present value of this is given, we can solve for the annuity. Correct? Let me explain this once again very quickly. What are we up to? What we are trying to do is effectively find out how much does this person need to invest in this period every year such that he meets his goal of withdrawing 25 million every year till the age of 75 post his retirement. He is investing 2 million every year between the age of 31 and 45. Fine. So we find the future value of this at 45. We find the present value of all these cash flows first at 55 and then at 45, discounting the same amount again. So what we find here is a needed fund, and we have accumulated fund. The difference between these two is what should be the difference should be the present value of all the 46 years to 55th year cash flows, these cash flows. This is what the difference has to account for. That's the present value of the difference. Now we can solve this multiple ways. The best way is to use the calculator. If you don't want to use the calculator, you can use Excel. You can use simple formulae of annuity, present value and future value as well. So I'll show you two of them and we'll get an answer through that. So the first one that we have is, let's say we use the annuity formulae. So as we go down, these are the two annuity formulae that we find. Fine, let me increase the font size slightly. Present value of an annuity is given by the annuity into 1 minus 1 plus r to the power n, n being the number of periods, divided by r being the rate of return. Future value of the annuity is again given by a similar formula, a into 1 plus r to the power n minus 1 divided by r. Effectively, if you multiply this formula into 1 plus r to the power n, you arrive at this formula. Fine. So if we solve using this, let's first find out the present value of the retirement annuity. So we calculate 1 plus r, which is this term, raise it to the power n, which is 20, n is 20 in this case, we get 6.73 based on that. Then we take the reciprocal of this, which is this entire term, 1 by 1 plus r to the power n, to get 0.15. Subtract this from 1 to get the entire numerator here, which is 0.85, and then divide this term d by r, which is the rate of return, which is 10%, to get 8.51. We get 212.84, which is the present value at 55 years. This is the present value at 55 years. Remember, we have to take it back to 45 years. So I take this number and discount it by another 10 years. How do I do that? I just take this number and discount it by 1 plus r to the power 10 to get 82.06 million is what is the present value of all the annuities that I will need post my retirement at 55 at the age of 45. This is at the age of 45, remember. Fine. Now we need to find the future value of these annuity points. Fine. So we'll find the future value of these annuity set of data. Let's try and do that. Future value formula is given here once again. So we calculate, remember this is 15 years now. So n changes to 15, 1 plus r to the power 15, 1 plus r to the power 15 minus 1. So the numerator is 3.18. Divide this number by 10%, which is the rate, we get 31.77. The future value is effectively annuity value, which is 2 million multiplied by 31.77, which is this entire term. So this is what is the future value at 45. Correct? So we have found the present value of the cash flows that we need. The annuity that we need is given here. We have found the future value of all these, which is given here. The difference of these two, which is 18.51, is what we have to fund effectively. This is what we will need eventually. This is the present value of all the cash flows that are coming. Now we need to effectively solve for the present value formula once again, which is given here. So we once again solve for, we have the present value now, which is 18.51 million. So what we have effectively here is an equation that can be solved by 18.514 is equals to annuity into 1 minus 1 plus 10% to the power 10 divided by 10%. We can solve this to get the answer for A, which works out to 3 million per annum, 3.01 million per annum. So if you solve for this, this is 1 plus r to the power n. This is the reciprocal of 1 plus r to the power n, which is given here. You subtract this from 1, you divide this by 10%, and you effectively take this and divide 18.51 by 6.14 to get the value of A. Once you get the value of A, you find that as 3 million. So that's the way to use if you are using the formulae. As I said, the simpler method could be just to go ahead and use the calculator. So if you are using the calculator, this is what becomes. If you're using the calculator, first you will solve for the PV based on these numbers, where you will put in N as 25, PMT as 20, I by Y as 10%, and solve for the PV. Excel incidentally has a function, so I will probably use that very quickly. I've actually used it on the right side, but I'll show that again. So let me delete this and solve this somewhere here. So I'm finding the present value, assuming this rate, assuming number of periods, which is, I'm sorry, I think I've made a mistake. The number of periods should be 20, the PMT should be 25. So if I solve for this, I'm finding the present value. The calculator does exactly the same thing. You just need to be sure about what you're putting in. I by Y, number of periods is 20. PMT is 25. And this takes something called type, which we have said is end of the year. So we put 0 there and end. It gives me minus 212.84. The sign being negative because I have assumed this to be positive. If I change this to be minus 25, I get 212.84, which is the present value at 55 years. I have to now take this present value to 45 years. Note that this is the same present value, 212.84, that we had calculated here in this cell. So you get the same formula to solve this. Next, you can go ahead and solve for the future value, where payment is 2, and you can solve for this now. So let's solve for this very quickly. The future value of this interest rate, which is I by Y, number of periods 15 years, payment 2, and once again at the end of the period, and we close this, we get 63.54. Once again, if I change this sign to minus 2, we get 63.54, which is what we had calculated here in this cell. We can take the difference and eventually solve for the overall number. Fine. So whatever way we use, this is the way we have to solve this. Now remember, what is necessary is for us to frame the problem. Once the problem has been framed, after that it is just a question of quickly inputting numbers to the calculator. That should not take too much issue. Even if this is at the beginning of the year, that should not change things dramatically. In the calculator you get it directly in terms of changing the mode to beginning. But even if you want to solve using the end mode, you can go ahead and solve. You just need to be careful of when the payments are happening. So just to give a quick example, if this was happening at the beginning of each year, then effectively and note that beginning of one year is the end of the last year. So what you could have assumed is that you start with 25 today, and then you have these payments happening all the way up to the next 19 years, and the last year is basically not there. You could have solved it for this, where you find the present value of all these 25 million cash flows and add 25 to that to find the present value here. That's assuming the payment is happening at the beginning of the year. We had in our question the payment happening at the end of the year. So what is important is just to create